Is it really possible to revolutionize your financial analytics with just one tool? Could DBT be the game changer? What is DBT? DBT, which stands for Data Build Tool, is an open source tool that enables data analysts and engineers to transform data in their warehouse. Essentially, DBT takes care of T in ELT, extract, load, transform process, by transforming raw data in the warehouse into structured, queryable data models. Key challenges in data transformation. First, complexity of transformations. Data often needs to be aggregated, normalized, and denormalized, or otherwise manipulated in complex ways to meet analytics business requirements. So writing and maintaining the code for these transformations can be challenging, especially as the business needs evolve. Second one, data quality issues. Poor data quality, including missing values, duplicates, and inconsistencies, can significantly complicate the transformation process. Ensuring data cleanliness and accuracy requires robust data cleaning and validation process. Next one, scalability. As data volume grow, transformations that were once efficient can become bottlenecks. Scaling data transformation process to handle large database without compromising performance can increase costs. It is also a common challenge. Integration of diverse data sources. Organizations often need to transform data from a variety of sources, each with its own format and schema. Integrating and standardizing this data to create a unified view can be very complex and time-consuming. Real-time data processing. With the increasing demand for real-time analytics, transforming data in real time presents unique challenges. It requires technologies and architecture that can process and transform streaming data with low latency. Managing dependencies. Data transformation often involve multiple steps and dependencies between these steps and datasets. Managing these dependencies, ensuring that data is transformed in a correct order, and handling failures gracefully can be a challenge. Next, data governance and compliance. Ensuring the data transformation process comply with data governance policies and regulatory requirements, especially when dealing with sensitive or personal data, adds another layer of complexity. Version control and collaboration. Collaborating on data transformation scripts and maintaining version control can be difficult, especially in teams where multiple members are working on the same data sets, are working on the same transformation logic. So these are some of the challenges that we can see with the transformations. Is there any transformation tool that can effectively address these challenges? Let's explore Data Build Tool aka DBT. It is claimed to be the new standard for data transformation, a SQL-first transformation workflow. The first one, develop faster. Replace boilerplate data definition, data manipulation language with simple SQL select statements that infer dependencies, build tables, views, and run models in order. Develop code that writes itself with macros, reference statements, and autocomplete command in the IDE. Make use of Python packages to speed up complex analysis. Second one, work from the same assumptions. DBT's pre-packaged and custom testing helps developer create a paper trail of validated assumptions for data collaborators. Auto-generated dependency graphs and dynamic data dictionaries promote trust and transparency for the data consumers. Next one, deploy with confidence. Build observability into transformation workflows with in-app scheduling, logging, and alerting. Production policies on branches ensure data moves through governed process, including dev, stage, and production environments generated by every continuous integration run. Next one, eliminate silos. Now your data science team can build models that connect with those built by the analytics team, each using language they prefer. DBT supports modeling in SQL or Python, enabling a shared workspace for everyone that works on analytic code. So another one, governance. Eliminate data doubt with version control, testing, logging, and alerting. Snapshot is a feature that changes over time and provide open access to hosted documentation. Transform your data where it lives. This is very important one. Whether you analytics data is stored in cloud data warehouse or data lake or lakehouse, you can transform, test and document it with DBT. Now I'm going to demonstrate DBT tool. DBT is available in two ways. One, DBT core. Second option is DBT cloud. If you are comfortable working using your own IDE, then preferred choice is DBT core. You can install DBT core through command line and work with your preferred IDE. Otherwise, if you prefer a cloud version, you can go with the DBT cloud. So DBT cloud comes with a cloud IDE. There you can do all the development, deployment, everything possible through DBT cloud. For this demonstration, I'm using DBT cloud. As you can see, this is DBT cloud. In this, I already have a project. When you are new to DBT cloud, first thing what you have to do is that you can go to account settings and then you have to create a project. I already have a project created, Redshift. So here I'm using AWS Redshift as a cloud data warehouse and using GitHub as my code repo hosting service provider. And I have the connection information, how to connect to the Redshift. You need to configure the connection information to your cloud data warehouse. So once you do that, then you can go to Cloud IDE. This is where you can start writing your code. So this project I've created as per the best practices of DBT. As you can see, these models, this is where the core part of our transformation logic resides. Outside models, the other important thing is that this DBT project YAML, this is where you can configure your project-wide settings and paths to various features like seed path, macro path, snapshot path, models path. So if you want to deviate from this structure, you come to this YAML and you can give folder name where your models are kept. Okay. So now let's get into the models. So if you see the models, I group them into stage, area, intermediate area, marks area. Okay. First, let's do the stage, source YAML. Okay. So in this YAML, I've given the information like what are the tables that I'm going to refer in the transformation. So this is where I've given the names of my tables: raw loan borrowers, raw loan payments, and these tables can be found in the public schema. Okay. As I have shown you earlier, I'm connecting this project to the Redshift. Let's go to Redshift. So this is my Redshift query editor. You can see here I have a dev environment, a public schema. Within public schema, the two tables are there: raw loan borrowers, raw loan payments. These are the two things. Like now, if I can query, I'll get some sample data. Okay, you see here, right? Or you can also loan payments. Yeah, you see the payment information. To just give a brief about what I'm doing with the data, let's say this is a fintech company or a financial service company who are into lending. Okay, for such kind of companies, usually it is very common that one needs to store the borrowers and then every month they collect the payments information. So let's say these are the two tables. The borrower table contains information about all the borrowers, and payment table contains payment details of these borrowers paid on monthly basis. Okay, so I'm going to consume these two tables information, and I'm going to create fact table and dimension tables and use these fact and dimension tables to create a data mart so that it's easy for analytics team to come up with any reports based out of these borrowers and payment information. Okay, so now let's get back to the project. As you can see here, go to borrowers, stage loan borrowers. What I'm doing is stage area. In this stage area, I am getting the data from the source, from public schema, raw loan borrowers table. I'm getting that source information, and then I'm selecting whatever the fields that I going to use are helpful for the analytics, and added an additional column, age. This will calculate the age based on the date of birth of the borrower. Okay, and this is going to be now stored in stage loan borrowers table. So whatever the name that you give to the SQL file, that is the table or view get created in your data warehouse. Okay, and then if you see this one, stage loan borrowers YAML file. Okay, what is this YAML file? So this YAML file, you can configure any tests that you want to perform on this particular table, on this model. Okay, so what is the test I have? Like no borrower ID, on borrower ID, I have this test. It should not be null and it should be unique, right? And another thing, you can add description so that later documents are generated. It comes out with whatever the description that you give for each model and columns. Okay, so that's why like no all the documentation, the better the description you give, the better documentation you get. Okay, so this is one test case. And then this is the second stage table for loan payments. So same thing, I'm getting the information from raw loan payments from public schema, and here I added another column called days late. It's just to calculate like if the payment comes later the scheduled due date, so how many days it came after the due date. So this information gets stored in stage loan payments table. Okay, let's go through some of these options here, right? Once you write your model, if you want to see if it is good or not, you can click on compile selection. It will compile your code so that you can execute on your data warehouse or your on the SQL admin. You can run it and you can verify if it is good or not. Okay, here you go. So here is how, like now if you look at it, like now the source function is now converted into like no Dave dot, this is the environment name and this is the schema name, this is the table name. Okay, and if you want to see the data, you can click on preview selection. Okay, it's just refreshed again, so the data is good. So you can see all the data that's selected by this CTE, days late. This column is also added. Okay, and one important thing, another feature is lineage, data lineage. You can see that how the data is flowing from loan payments, it is going to stage loan payments, and then from it is there going to fact table loan borrower payments, and then marked payments by state. So this is going to be very helpful for troubleshooting and also for the data governance, this lineage. So then from here, you can next go to intermediate. In the intermediate table, what we are doing, so first I created fact table. So I clubbed borrowers and payments tables. So you can see the entire lineage, how it is going, how this loan borrower payment is being created based on what are the models, what are the dependencies. You can see everything in this lineage. So if you look at it like step by step, we are getting the data from borrowers, payments, and states. Okay, this is the dimension table. I'm using it, and then I partition payments for borrowers, and then I taken the latest payment, join latest payment information with the borrowers to get the borrower payment fact table. And then here are the dimension models that I have created. I created a age dimension, state dimension. So in the state dimension, I've added a region column along with the existing state, so that it will be helpful if analytics team want to get some stats based on the region, not just the state. Once I have this intermediary, then final, I have the marts. I created one mart model. It's basically payments by state. So what I am doing here, I have selected data from the loan borrower payments fact table and then the state dimension, and I join this. I'm trying to get payment status by state and by region. So this is my final mart model. Okay, so as you can see, everywhere you are going, right, you know this lineage and everything is available. And one other important feature in DBT is testing the models. Okay, let's try how the testing of a model works. Okay, so here is our stage loan borrowers, and then here is our test. We have a test on the borrower ID, not null, unique. Okay, so if you want to test it, you can come here and you can test the model. DBT test fail. Okay, so if you want to know the reason why it failed, you can come here, you can see all the logs. Okay, not null stage loan borrowers. Okay, I understand that. The reason is that it was not built at all. So what you have to do is that you have to first build it. So the data will be there and then it will execute the test. Like now you see that it got succeeded. So that's how we'll do it. Now let's get into deployment. Okay, so I have like production environment I created. So it will tell like the prod environment. So that I have here the prod environment credentials are there. So DBT prod schema, that's where it's going to get deployed. Go back and run the job, prod job. Okay, so the job is successful. If you click on it, you can see all the log, like it clone the Git repository, connected to Redshift, and then it invoked DBT deps, DBT build, DBT docs generated, documents also generated. Okay, so now if you want to see the documentation, if you click on view, you will get the documentation. Of course, the documentation you will get based on whatever you add the description. So you can see the DBT prod, you see all the models that are there. Then if you go to, for example, stage loan borrowers, now you can see what are all the columns that it has, what is the model, and all that information, and then you can get the description here. So this is going to be very, very helpful, all this documentation. So now let's go to data warehouse and see whether it's really deployed the project onto the data warehouse. Okay, so dev environment, you can see DBT prod in the schema. Oh, there you go. You can see that. So all these views are created. So let's query DBT prod schema payments by state. Okay, we got this error because I didn't commit my changes to the main branch. Let's commit these changes and rerun again. Okay, so now the changes are committed to repo. Let's rerun the deployment job again. Rerun now. Okay, job has been completed. Let's go back to Redshift query editor, refresh it. Okay, so dev, so you have dev, so DBT prod, you run the mart, payments by state. Yeah, there you go. So you got state, region wise, the payment status, various payment status, and then the payment status count. Okay, so you see that it's very flexible tool and a collaborative tool to do complex transformations. Let's discuss about limitations. First one, integration with real-time data processing. DBT is designed for batch processing and may not be the best fit for real-time data processing needs. Integrating DBT with streaming data sources and performing real-time transformation requires additional architecture and tooling. Second one, limited to transformations, just the transformations. DBT focuses exclusively on the transform part of ETL. It does not handle the extractions or loading of data, which means you need to use other tools or process for these parts of your data pipeline. Third one, performance in large datasets. DBT performs transformations within the database, relying on the database computational power. For extremely large datasets or complex transformations, performance might be limited by the database's capabilities, leading to longer runtimes. If you are using in cloud warehouse like Redshift or Snowflake, this is not a problem. But if you want to execute in standard databases, yes, it's a limiting when you have high volume of data to process. I hope this video is helpful to you. Have questions or want to see more about specific feature? Drop a comment below. I would love to hear your thoughts and suggestions for future videos. This is Sagar signing off. Keep transforming and stay data savvy.